we are here today. I'm here representing IST INTECH. We are a manufacturer of UV LED curing devices. Historically, the company was founded as Integration Technology about 25 years ago. And originally we made UV lamp systems for the wide format digital printing market. We realized quite early on that UV LED was going to be a breakthrough technology in not only wide format printing, but in various other areas as well. So we started a lot of development for that. So with that, UV LED development has come along significantly, particularly over the last sort of 10 to 15 years, and that has opened up a wide range of applications in which we've been able to explore with UV LED curing lamps. We offer a wide range of lamps. We have standard lamps which we will then tailor to customer specifications. We tend to sell to OEMs directly, so we work closely with these OEMs in order to provide a solution that fits for them and their particular application. Just on our products, we can also offer bespoke solutions. So we have what we call a standard Lego building blocks, and we then use these to provide a bespoke solution for customers if it is a new application or a new area that we're looking into which our standard portfolio would not fit into. So, LED curing. LED curing has come along quite a lot, as I mentioned, and there's various reasons for this. You do have increased productivity with LED curing. It is an instant on-off, unlike the traditional UV lamps, which you need a warm-up and cool-down period for. You can use a wider range of heat-sensitive materials for printing with, and you can immediately handle these, so there's no waiting time for post-curing. LEDs are seen as a more sustainable solution for the future. You have reduced pollution. There's no need for big extractions because there's no VOCs. So in terms of space in factories, they are a much smaller footprint than traditional arc lamps. And yeah, instead of mercury lamps, you have LEDs, so that eliminates the need for mercury. You're reducing waste because of the lower heat output. You can use thinner film materials. There's less maintenance required with LED lamps. You aren't having to change the LED modules as frequently as you would change a UV lamp. For example, the LED module should last 50,000 hours plus. And you don't have spare parts like reflectors. These are no longer needed. There's no ozone, no harmful VOCs, and no mercury, so it's a much greener technology than traditional UV lamps. And it's a lot more efficient. You have the instant on-off, less energy, and the majority of UV LED lamps have a lot more controllability. So a UV lamp tends to be made up of multiple LED modules. You tend to be able to control each LED module or a section of LED modules independently. So you can turn on only the LEDs that you require for the print job you are doing at the time. You don't have to have the complete width of the lamp on. But what is next for UV LEDs? So UV LEDs have developed a lot. They've got a lot higher in power. There was the intensity race as to who could get the highest intensity, and now in the last few years particularly, it became more apparent that it was more about the dose rather than intensity as such. And over the last few years, you've seen a lot more higher dose UV LED lamps. But what is the next step? So for us, the next step is smart UV LED curing. Everyone is talking about Industry 4.0, the factories of the future, dark factories, and in order to move along with the times, the LED curing lamps also need to do this. So they need to get smarter in how they work. A lot of LED lamps now and in the future will have remote monitoring and maintenance. This gives end users the opportunity to make real-time adjustments, whether that's product related or print related. You can have real-time monitoring of the component parts in the LED lamp system or of the outputs that it's providing. And this really does mean that you can maintain easier. So you can put in preventative maintenance plans and predictive maintenance plans. So an example of this could be the LED feeding back to you that on the LED module you have various LED dyes. An LED dye has failed, but you can still print because you're still gaining the output that you need to cure with the lamp. Then, for example, if the whole LED had died, the system can tell you this, make it clear you need to stop production and repair the head. Or it could be something as simple as the temperature's increasing, you've got an air-cooled lamp, you need to increase the fan cooling to ensure you have a stable output across the lamp. So this can all be done using advanced sensors to measure, again, not only the internal components, but the outputs. One of the things that you could be looking at is your machine could be telling you, yes, your LED is working, the current's correct, there's no problem, you are getting the output. But actually, in reality, you're in quite a dirty environment. This has caused ink mist or contamination to build up on the front of the LED unit. And this means that actually, although the LED lamp internally believes you're getting the output, you're not. So you can use things like the cameras that were mentioned yesterday to view the lamp head and feed back that actually, no, you've got a spot of ink contamination on the front face, which is going to obscure the curing and cause a fault in the print. So, and again, this can be done various ways through transmission of data. It could be put on a HMI, which is at the customer site. It could be done via remote monitoring of the machine. So there's various different ways forward in order to meet the needs of the future requirements. And that is what it comes to. It is about using smart lamps for real-time adjustments, for adjusting your UV LED lamp to what you are printing there and then, for the machine to be able to do that for you, so that you can load in your print jobs and the LED knows exactly when to change from one width to the next, when to lower the intensity, when increased intensity is required, and be able to, and this all allows for a smoother operator experience. If the machine is doing this and learning, it's needed. But in order to do this, we do need to also collaborate with various other people within the industry. So we do need to work with people like printhead suppliers, the ink suppliers, so that we can learn with them to see what is best and what is required. And this will all be done using predictive analysis and machine learning. And there'll be a lot of data required and a lot of work in the background. But we believe that with the use of AI, which is quite a hot topic at the moment, this will move forward quite quickly. We think a lot of this has been discussed, and some of it is even implemented already, but we believe it is the future on where LED lamps will be going. So I'll pass over to Simon to discuss a little bit more about the whole ecosystem.
Yeah, great. Thanks, Lizzie. Yeah, so where I want to kick off from this is talking about not just artificial intelligence, machine learning, but a number of different things. If you go back to the picture of the lamp that was there earlier, the ideal scenario is that in fact an entire machine is run based on the image content that's being printed. Because there's a lot of things inside a printing machine you can manage based on knowing what the image content is. And lamps is a great example. Why turn on a lamp if you don't need to? Why use more energy if you don't need to use it? Just blindly turning on curing systems without knowledge of the image seems like a waste of energy and a whole lot of other things. It also means if you're constantly using a device on a machine, when it doesn't always need to be, there are certain things that will change in that device and it will need to be replaced. So one of the key reasons for collaborating, one of the collaborations or the collaboration between GIS and IST is this idea of image-aware content. We manage the image. We know what the inbound image looks like. We should therefore turn the lamps on when they're needed to be turned on with the right amount of energy in the right place. If there's no image in one segment of the lamp, why turn that on? So where we're heading as an organisation is around image-aware technologies. Now, that's not necessarily artificial intelligence, and I'll come back to that in a minute, but it is intelligence of a sort. So to do that, we need to have control or feedback as well. So we need to be able to control those things from where the image is created and where we know what things look like. And in some cases, it's not just the PDF content coming in, because what's coming out is in fact a screened output. There's dots in certain places, and that can change depending on the printhead technology you're using or the device. Also, whether in fact you've stripped out a varnish layer or not, or whether it's just the colour component, or it's an adhesive component that's been going down. So you need to get that tight integration into the data path. In addition to that, you need to have devices which are intelligent. And so one of the things we've been working on with IST is in fact the device that couples between the lamps and the data path. So our RIP engine works directly with the IST lamp control system. And so that means as we're ripping the data, as we are controlling the print job, as we get a trigger to start printing or stop printing or pause, or there's a gap or there's white space in the image, we control the lamps in real time. So we're doing a real-time control system. Now that concept flows all the way through. So for example, our drive electronics, we've just recently gone through an update on our drive electronics. So our drive electronics now has intelligence built in at the drive electronics level. And all our future products we're rolling out, and you'll see a lot more this year and a lot more next year, will all have intelligence built in. What that means is, when you look at a machine with 250 print heads in it or more, and then we've got customers who have at least 250 print heads in a machine, that 1200 DPI, the amount of data collected is phenomenal. And you can't store all of that. So you need intelligence as far downstream as you can get it. And so that's what we're starting to roll out now, intelligence electronics. IST is an example of one of those components. Our drive electronics, our ink systems. We've got a lot more partnerships we're working on where we're doing the same thing. Working as a collaboration to make intelligent electronics to make sure the data path and the devices work in synergy. You can't store all that data. I mean, we're talking about enormous amounts of data. Even something like a single temperature sensor in a system is constantly changing all the time. You need to know whether that change is worth doing something about. Because if it's not, don't record it. But if you've got a device which is just blindly sending temperature data, it changes every 0.1 of a degree, you've got massive amounts of data that you don't know what to do with, and you've got to process and do something with it. So intelligence downstream, far down as you can get it, is really important. And so that's where we're heading with these things. And then what we've got is upstream, we are taking what we need, just the pieces we need from that intelligence data, and doing something with it. If you could just move to the next slide. So in that framework though, there's two things which are quite important. There's what you call real-time intelligence, artificial intelligence, which is basically saying, I don't have time to store it and do something offline on a massive computational computer of some sort. I need to do something locally. So it's a combination of what can you do as a local intelligence at the PC level that you're working with that's connected to the device, and what do you actually need to do on the back end. You'll have heard about the collaboration between FIRE and ESCO and GIS and IST and others. And that collaboration is all about managing the big data streams that come through. All of those companies have now got a lot of focus on intelligent technologies that are intelligent around the data path, around the devices, and around all sorts of other components. And they've got to work in synergy, because again, we can't move into a world where you've got terabytes of data that you need to somehow process. You need to do it as every step you possibly can in a huge amount of synergy. We've got an example now where we have several customers with on-machine inline camera technologies, and these work very well. So we're able to correct missing nozzles, we're able to correct density. We're going to be able to do things like measure the output and see whether in fact the UV lamp energy, for example, is appropriate for the jobs or not. And you can see how far that can go. So as you keep going through that process and you say, if you've got these ability to sense things on a device, you can change a lot of parameters around your machine. And you can use that to change the nature of the jobs. You can do things like predictive maintenance. You can look for potential failure modes. You can adjust parameters and optimize in real time. And for us, that's what 2025 is all about, rolling out intelligent technologies, high-speed data stream management, and on top of that, applying basic artificial intelligence, mainly machine learning. I don't see a lot of deep learning needs for the next couple of years, mainly around machine learning technology, which is all part of the AI. But it's also about using these things in an intelligent way. You know, a lot of the stuff will be under the hood, will be hidden, because that's how it should be. I mean, I gave a presentation last year, which was I showed a video of one of the original Apple videos about interacting with AI, where basically you don't see the AI, which is what we're looking for, is technologies which you don't have to think about as customers. It's just sitting there in the background doing what it should do, making some decisions where it can, or highlighting upstream through the UIs things that you need to be aware of, but not having to have the user go through hoops and loops trying to work out how to use these tools. So we're pretty excited about the future. We're very excited about our interaction with IST.
Yes.
And we can see a future where some of these things will start to build in, and 2025 is the year, I think, where we're going to start to see a lot of these very basic things come in a very useful way, not in a way that just looks like it's going to be useful, but actually is.
Yeah. So we have already started with Atlas Ready. So this means that our UV LED lamps can be controlled via the Atlas software. And this is, as Simon said, one of the steps we're taking in order to make sure that our UV LED lamps are ready for the future. And as he said, not just smart lamps, but useful smart lamps that work in the ecosystem of the digital print world that can work with all our partners. So, thank you very much.
Thank you. Very good.